Hello, this is part of the Neuromorphic Computing with TENNLab video series. My name is Jim Plank. Video is entitled the TENNLab Software Overview. Its intent is for anyone who wants to use our software as kind of a good starting point for getting your bearings and knowing where to go. Our software is hosted on Bitbucket and it's a private repository. So if you want to make use of it, you need to email either me or Katie Schumann, and we will invite you to the repository. We have two different workflows on how we use our software. The first one is a Python based workflow whose intent is basically to be kind of in the same guise as a lot of machine learning toolkits, so that if you've used Keras or scikit-learn, then the procedures will be kind of familiar to you. There is also a C++ workflow, which is probably more for programmers and for people who want to do detailed research on detailed components of the framework. Katie manages the Python workflow. I manage the C++ workflow, so that's who you can direct questions to. In the big picture, this is what our software looks like. We have neuroprocessors, which in software are typically simulators, and we have multiple of these for multiple neuromorphic processing systems. Our framework is intended to do research on neuroprocessors. So if you want to develop your own, you can develop your own simulator and it should work in our software. Then there are applications, and our applications are more than just classification. We also have regression and a suite of control applications, plus support for other application suites such as OpenAI Gym. Then there's the framework. The framework specifies the interface for the processors and the application. Plus, it has support for training and different modules for things like encoding values into spikes and decoding values from spikes, etc. And then finally, there are a whole bunch of other modules that we support, and I'll go into those in the next few slides. So, neuroprocessors are supported by defining an interface. The framework defines the interface that a neuroprocessor simulator must implement. In other words, it specifies the methods, and the neuroprocessor must implement the methods. And these are things like load a network onto the neuroprocessor, apply input spikes, run, maybe probe for output spikes, etc. Typically, these simulators are written in C++ for speed. So there's Ravens and RISP, which are both part of the framework, Caspian's and Oak Ridge project, and there are others. And then they may also be written in Python, but then there needs to be some glue to get them into our framework. But we do have that glue for various Python neuroprocessors, such as Brian, Nest, and Ningo Luihi. Now, applications come in several guises. In the first, you can write applications that simply use the processor interface directly. So there's an application we have called the processor tool, which basically gives you a command line interface where you can load networks onto a processor, apply spikes by hand, probe the network by hand, so that you can see how the processor works. But you can also write applications that simply work on top of the processor interface. Second, we have an application interface defined by the framework, and then if you want to write an application that adheres to this interface, then you get a whole lot of support from the framework. The interface is very much like OpenAI Gym, where you have step and reset functions that will present you with observations and then take actions as a result and give you reward. And there is a piece of software in the framework called the App Agent, which will then take an application that adheres to this interface and give you support for training it and testing it and doing demos with it. The framework itself is kind of the central glue of our software. As I said previously, it defines the processor and application interfaces, and then it also defines various methods or procedures that you can call on various parts of the framework. So, for example, spiking neural networks have their own definition and then their own operations where you can construct them, modify them, prune them, and get information about them. It also defines encodings to spikes and from spikes, and there is support for changing these at runtime, and they implement many popular encoding schemes such as population coding, rate coding, temporal coding, etc. And then, as I mentioned in the last slide, there is an app agent that trains and runs applications and can also help with demonstrations and with doing research. And then finally, we have the machine learning and other modules that are supported by the software. And this is not an exhaustive list, but I will mention some of them. There's EONS, which is a genetic algorithm tuned for neuroprocessors. That's been the workhorse of our software framework for years. We have a different genetic algorithm, LEAP, that's supported. We support Whetstone, which is a spiking neural network training module in Keras that we can then port into our framework. And then there are other training and optimization techniques that we support, like the two listed in there. So I'm just going to run through 3 example scenarios of things that you might do with our framework. So the first would be doing classification in Python. So the way you do such as, I'm just going to give you an overview of the steps just so you can get that you can get some intuition. So the first thing you have to do is make the Python environment, which is going to involve compilation, etc. with a script. You only do this once. Then you're going to start Python, import various packages like scikit-learn, and like if you have a data set that's implemented in a Python package, then you would import that. And then what you do is you're going to select the neuroprocessor, the data set, and whether or not you're doing classification or regression. This is all inside your Python environment. You select a spike encoder and a spike decoder, or you use the default values, and then you can train using EONS. And when you're done, you'll have a network in your Python environment, which you can export to the file system. But then you can also use it for testing, and you can use tools that may be familiar to you, such as scikit-learn's processing and visualization tools. So again, the goal here is to try to make the workflow familiar to you if you are familiar with some of the Python machine learning libraries. As a second example, in C++, things are a little different. Now, what I'm going to give an example here is of a control application, such as the cart pole application. This is our own, not OpenAI Jim's. The way this works with C++ is you select the application in the processor, and then you compile. And there's an example of compiling. And what that does is create an executable file for you that simply runs that application on that neuroprocessor. So it's different from Python, where everything's loaded into the Python environment. With C++, you've got to create your own executable, which you'll then run. So then you can run it in training mode, specifying the spike encoders and decoders, and then that will train using EONS, and the result of this will be a network that has been trained to have the best fitness. And then when that's done, you can rerun the executable, but now in testing mode, where you can then perform testing or analysis or analyze the behavior of the neuroprocessor while it's running, etc. And all these things are supported inside that executable. Oh, and sorry, you can also specify things like files to put output or sockets which will be running visualization tools or application visualization tools, and they can all run in concert together. Third example, let's suppose you want to train a classification network using backpropagation. You can use the Whetstone module inside Keras to do this. And when you're done, we have a porting tool that allows you to port the Keras Whetstone network into a TENNLab network. And then we have a application that you will compile, and then that application becomes a classification application that uses the network that you ported from Keras. This is the last slide. At this point, you should figure out which workflow you want. Typically, that's obvious depending on how you do research. And then with Python, there is a sequence of Jupyter notebooks in the example subdirectory that Katie has made to help you start walking through how to use the Python workflow. There will be videos on our website about Python. They're not yet, but we are making them. With the C++ workflow, we have made multiple videos to help you start walking through and getting started. There is documentation in the Markdown directory. There's a few Markdown files you should scan through, and then the detailed walkthroughs that correspond to the videos that are on our website are in those two Markdown files so that you can have a hard reference for the walkthrough in case you'd rather do it at your own pace and not work with a video. Thank you.